everyone. Welcome to the video. Today we are going to solve the problem minimum platforms. In this problem, we are told that there is a railway station. We are given that few trains arrive and depart on that railway station. We are given their arrival times, we are given their departure times, and we are asked that what should be the minimum number of platforms at that railway station so that no train is kept waiting. It is also given that all the arrival and departure times are on the same day. Now, we often complain that we don't find a direct application of data structures in our real life. Well, here is a question that applies data structures to a real life problem. Also, I'm sure we have been in situations where our train was stopped at the outer, was kept waiting at the outer because there were not sufficient platforms available. So we'll try to solve this problem today. We won't directly jump to the solution, but we'll try to reach there step by step, thinking through. We discuss the questions of data structures and algorithms on this channel in simplest words with fundamental approach. If you are new to this channel, please subscribe. To begin with, let us first try to note key things given in the question. We are given a railway station, arrival times of few trains, departure times of few trains, and we are asked what will be the minimum number of platforms. If we take an example, here are the arrival times given, here are the departure times given, and in this case 3 will be the minimum number of platforms. Why is this 3? We will see this later when we try to solve the problem. If we consider our solution as the black box, we are getting as input arrival time array, departure time array, and the size. And obviously the sizes of both the arrays will be same because a train that arrives will depart as well. And we have to return the minimum number of platforms. So if we see what will be the function signature, this function takes an arrival time array, a departure time array, and its size, and returns an integer. One important thing to clarify here is what will be the input type of arrival and departure times. This could be, while we have taken here as int array, otherwise this could have been very easily a string array. Instead of 0900, it could have been represented as 0900:00. It could have been represented in the form of absolute minutes, that how many minutes since 0000. So it is better to clarify the format of the times with the interviewer before we begin with the question. For our case, we are taking the format HHMM, right? So in that case, basically the first two letters represent the hour and other two letters represent the minutes. And even this number of minutes could even be greater than 60. For example, 2180 is a valid time. That means 21 hours have passed and 80 minutes have passed. And so we can calculate what is the time. Now, before jumping into solution, let's first only try to visualize it. How will a typical day at railway station look like? We have constructed this timeline from 00 to 23:59, and here we are taking into account these arrival and departure times that we are given, and we'll see how this plays out in the railway station. So let's begin. So first train arrives at 0900 at 9. That's good. This one gets departed at 9:10. So we needed one platform here. Now second train arrives at 9:40. We keep it standing here. Then another train arrives at 9:50. We need another platform to keep it standing here. Then another train arrives at 11. We need another platform to keep it standing here. Now the next arrival is at 3. But one of the train departs at 11:20. So let's say this got departed. Now we need only 2 platforms. Then another train gets departed at 11:30. This is also departed. Then another train gets departed at 12. So this is also departed. Now next train arrives at 15 here. Okay. Similarly, another train arrives at 18, and now one of them departs at 19 and one of them departs at 20. So we needed 3 platforms here and we needed 2 here. That means the maximum platforms that we needed was 3, and hence the answer was 3. Now let us try to note what all we did here. First thing we did was sorting. We need some kind of sorting because we approached these times in a sorted manner. Second thing that we did was we did not approach these times separately, that we were looking at arrival separately and departure separately. This sorting was done overall on arrival and departure combined. So we need this as well. And we also need the information that whether this time is of arrival or whether this time is of departure, because arrival means we need the platform and departure means that the platform just got free. So what will we sort? We need some kind of data structure to hold this information. We need train time and we also need event type, whether it was arrival or departure. We can call this data structure something like train event. Let us now try to formalize our solution approach into an algorithm. Okay. So first thing that we'll do is we'll use those arrival and departure time arrays and we'll convert them into train events array. Train event is our new data structure which has a train time and an event type. Once arrival and departure times are converted into a train event arrays, we will sort it. Then we will iterate over that array, and whenever there is an arrival, we will increment some counter. Whenever there is a departure, we will decrement that counter, and at any point in time, whatever was the max counter's value will be our minimum number of platforms that will be needed. Now this seems like a good enough approach to work. But here is a catch. How will we sort it? We have to sort an array of data structure train event. Will arrays.sort work here? No, because Java or any other programming language doesn't know how to sort our custom data structure. So we'll have to provide them with a way to compare the two train event and decide which one is greater or which one is smaller. To sort a custom class or a data structure in Java, we have multiple ways. One of those ways is that class should implement a comparable class. So in this case, like our train event class is implementing a comparable class. Now, if we have to implement a comparable class, we have to override its method compare to. What does this compare to method do? This takes another train event and it will compare this train event with the current object's current train event object, and it will return which one of them is smaller and which one of them is greater. Now, how will we decide what is smaller and what is greater? Obviously, we'll decide it on the basis of event time. So let's compare two things. Let's say we have 1900 and we have 1920. Which one of them is greater? This one. How do we know? Because its actual value is basically 19 hours. That means 19 into 60 minutes plus 0 minutes. And its actual value is 19 into 60 minutes plus 20 minutes. Similarly, let's say it was 2180 or 2210. Let's try to compare which of them is greater. Now this will be 21 into 60 minutes plus 80 minutes, and this will be 22 into 60 minutes plus 10 minutes. So we'll find that this one is greater. Let's try to see what are we doing here. We are first splitting the time into two parts, hours and minutes. How will we do that? We can divide this by 100. So the quotient will be the hours and the remainder will be the minutes. And then we use this formula to arrive at the exact minutes, and then we compare the two. There are multiple common things to learn here which we can apply in other questions as well. First is deriving a new data structure, like we derived this train event data structure and put existing values into the new data structure. Second is sorting a custom data structure using comparable, like we overrode the compare to method. And third thing is often we need to split integer into two parts or three parts that we can always achieve by division, and we can use the quotient and remainder to see the split integer. For example, here 2180, if we divide it by 100, quotient will be 21, which is our hours, and remainder will be 80, which is our minutes. Now this was our original algorithm. Now we have sorted out all parts of our algorithm. Now we can see how this algorithm would work in code. Here is the code for minimum platforms. You can also find the link to this code in the description. So first of all, we define a list of train event. Before defining the list of train event, we have to define what is a train event class. So here is the train event class. It has two members, time of event and event type. Event type is an enum that has two values, arrival or departure. We provide the constructor for this class so that someone calling from outside can create a train event. And we also provide a compare to method. We need to provide this implementation of compare to method as we are implementing a comparable interface. And in this, how do we compare? We first calculate minutes from both the train events, the current one and this one and the one through which we want to compare. And then we compare the result and return. How do we calculate the minutes? We simply divide by 100 and mod by 100, and we apply the simple formula hours into 60 plus minutes. Okay, so this is the class train event. So in the main our method, we first defined the list of train events, which is an empty array list. Then we iterated through all the arrival times, and for all the arrival times we created a train event instance with event type as arrival, and we pushed that to this train events list. Similarly, we did that for the departure times, and we pushed that to the train events list as well. Then we called collections.sort train events. Now Java knows how to sort these train events because we have provided the compare to method. So hence it can sort the train events. Now we have the train events sorted. We simply iterate over this array from I equal to 0 to 2n, and in each iteration we have the train event. If the event type was arrival, we increment a counter. If the event type was departure, we decrement the counter. And we keep maintaining what is the max counter so far. And finally, we return the max counter so far, which will be our minimum platforms required. We first try to understand the problem with the help of an example. We also understood what could be the way in which we are given the input. Then we just tried to visualize the problem and tried to see how arrival and departure of a train will impact the platform need. Through this, we saw that we needed a new data structure called train event. We also needed to be able to sort it. And to sort a custom data structure, we needed to implement a comparable interface. We saw all of that, how to do that. And then we combined all these elements into our solution approach. We sorted these train events, we maintained a counter, and using that in linear time complexity, we were able to find what is the minimum number of platforms. We also went through the code, whose link you can find in the description. This is it for this video. If you have any doubts, please feel free to comment below. And we will meet again in the next video with some other problem. Thank you for watching.